If you like building boxes and have a CNC in your shop or looking to buy one, this video will demonstrate how a desktop CNC can be used to mill brass, make plexiglass templates, and make precision mortises for hardware installation.
2 years ago, I purchased an M500 CNC from Stepcraft. I bought it primarily to do inlays but found many other uses for it. For design software I purchased VCarve Desktop. This was about the time I came across Daniel Lucian's website at daniellucian.com. Daniel specializes in luxury jewelry boxes and cases from 19th century London. If you want to see some amazing examples of Victorian craftsmanship, I recommend you visit his site. David Edwards was one of the builders of this era. He produced this small jewelry box from around 1830. It has the typical rounded brass edges popular at the time, and a narrow brass trim inlay. I'll walk you through the process of building this box in my shop. My first task was to find some quarter-round brass bar. After an extensive search, it appears that brass bar is only manufactured in 4 shapes, and unfortunately, quarter round is not one of them. It seemed that my only option was to buy square bar and round them over. I decided I would use the CNC for this task. Here is the job I created in VCarve. I'll open the job setting panel and you can see I've got the drawing dimensions set for quarter-inch bar that is 14 inches long. To carve the quarter-round profile, I created a molding toolpath. You can find the tutorials on this toolpath on the VCarve site, but in brief, you define 2 main features, a drive rail vector to indicate the direction and length of the cut, and a profile vector. Here you see the tool path projected over 7 inches of the bar. Let's take a look at the simulation. The bit selected for this job was a quarter-inch ball nose with 4 flutes. To allow these bars to be mounted onto the CNC bed, I glued 2 pieces side by side, onto a sacrificial block of wood. Here you can see one side has already been milled. And here you can see the other side getting cut. After both sides were milled, I separate the brass from the wood on the table saw. It was now time to procure brass strips for the inlay on the front and top of the box. My design calls for 1/16 inch by 1/8 inch dimensions. And just like the brass bar, I could not find material in this size. I did find 1/16 inch brass sheets and decided to cut the strips from this material. My first attempt involved cutting these strips out on the CNC using 1/16 end mills. Although the bits I purchased are designed to cut soft metals, the feed and speeds on these small end mills are critical, as I found out. After breaking 2 of these bits, I gave up, and decided to try a different method. My next attempt would involve using the band saw. I purchased a 14 TPI metal cutting blade which provided some success, but as you can see I had trouble producing consistent widths. For this last attempt, I built a jig that will mount onto the CNC bed. The brass sheet is fed under a reference stop and then clamped down. I used my flexible shaft rotary tool with a 1.5-inch cutting wheel to cut the brass. It took a little experimenting to determine maximum speed and cutting depth per pass. These parameters were used to create a tool path that could run automatically. It took about 18 passes to cut through the plate. If I had a high torque motor, and a handpiece that could take a 1/4-inch mandrel, I could have used a 3-inch wheel, and this would have speeded things up. This method, however, produced some very nice results. The strips were very uniform in width with straight, smooth edges. After getting the brass problems resolved, I could finally start building the box. I used the same dimensions as the Edwards box, 9 by 7 by 4 inches. I selected a nice piece of Bolivian rosewood. Here you can see the front and side pieces cut to their final dimensions. The inlay mortise being cut into the front piece using a 1/16 end mill. The mortise for the top was cut after assembly. The miters were cut on a compound miter saw. I like to cut just shy of the end and do a final touch-up on a disc sander. This produces a very clean and accurate miter. The top and bottom pieces were made of Baltic birch plywood and 1/16-inch rosewood veneer. The corners were notched out to accept the 1/4-round brass bar, and the brass strips were glued into place. The metal cutting bandsaw blade turned out to be a good investment as it was used to dimension the brass bar, and for cutting the box open. A common approach to removing saw marks after cutting a box apart is to rub the cut surfaces against a large sheet of sandpaper with the paper mounted on a flat surface. A technique I've been using is to skim the surface on the CNC. I'll install a 1/4-inch down cut end mill. With the top section mounting on the CNC bed, I tap off one corner to establish the 0 point for the Z-axis. I'll move the bit away from the wood and drop it a 1/2 millimeter below the surface. To do this, I type Z-0.5 in the MDI box and then hit enter. I'll set the jog speed to 30% and turn the router on. I'll move the gantry around manually to skim the surface. Typically I'd skim the entire surface, but in this case I avoided the brass corners so I can come back and skim the brass at a much slower jog speed. It's hard to get this clean a surface using the sandpaper technique. I'm always impressed when I can place the top on the bottom and make it appear as though the box is still in one piece. This project called for a high-quality lock, and I found one on fineboxhardware.com. This is a full mortise lock that is manufactured in the UK. Back in Vetric v Carve, I created 2 jobs that will cut the mortises. The job dimensions for this drawing are not important, but what is needed is to set the X and Y datum at the center of the drawing. This way you can mark the location on your project where you want the pattern to be cut. The hinges used for the project were Brusso quadrant hinges. I use my engraving bit to position the gantry at the location where the hinge will go, and then zero the X and Y coordinates. This smartphone app from Stepcraft acts as a jog pendant, and allows me to get close to accurately position the gantry. Tool paths were created to cut both the hinge mortise and support arm mortises, and just for fun, I create a drill tool path to drill the holes for the screws. I've been disappointed with some of the escutcheons I've purchased in the past, so I made a few on the CNC. These were cut into 1/8 inch brass. I cut one out and filed off the tabs. I made this template on the CNC so the escutcheon mortise could be milled using a router with a bushing. From the CAD drawing of the escutcheon, I offset the pattern the appropriate amount to compensate for the bushing. The large pattern is used to fit the escutcheon and the small pattern is used to cut through to the lock. Here the template is in place and secured down with double-sided tape. With the router depth stop set to 1/8 inch, I'll go ahead and cut the mortise for the escutcheon. Here I've finished cutting the through mortise with the smaller template. Sanding Bolivian rosewood to 400 or 600 grit is typically sufficient, however sanding the brass to a bright polish takes a lot more elbow grease and finer grits. These flexible sanding pads worked well for this project. They come in various grits down to 3000. The finish I used on the box was a gloss lacquer. I normally use a satin finish but didn't want to take anything away from the brass. This box was a lot of work, but I was happy with the final result. I gained a lot of respect for the work produced by Edwards and other Victorian box makers.